Hello everyone, welcome to my channel Middleware Technologies. Today we'll be looking at how we can build a customized fedora system image using a tool called OS Builder. Okay, so let us try to understand what is actually a customized image. Okay, so in this video I'm going to use this tutorial as a reference to show you how we can build a customized fedora image using some kind of definition files, and before that we will be going to install some prerequisite packages to support this activity. Okay, so let us see how we can go in this tutorial. So first of all, let us try to understand what is an image builder. Okay, so image builder is basically a tool that is used to build a customized system image with a set of with a definition file, which is actually a blueprint, we can say, which consists of what type of packages that we want to install and what type of customization that we want to define in the image or the operating system that we want to build. Okay, so that is what the image builder tool is going to do, and it supports various kind of formats. So if you see, like we have a lot of virtualization is a de facto standard like in today's world. Okay, everything wants to be whatever we are going using needs to be virtualized. Okay, so we have virtual machines, we have virtual storage, virtual networks, so everything is kind of a system which is defined in a virtual format. Okay, and there are a lot of cloud providers and vendors which support different formats of these virtual resource definitions. Okay, so let's say we have VHD, we have VMDK, we have AMI that is supported by Amazon Web Services, and we have VMDK, okay, VHD. So these are the different formats that are created which define the system image. Okay, basically which build the system image. Okay, so these are the formats that we can build using this image builder tool. Okay, so for that purpose we need to install some set of packages which we will see in this video. Okay, so let us go further and understand what is a blueprint. Okay, so blueprint, as I mentioned, is a definition file which is written in terms of this minimal language. Okay, TOML language. It defines the packages and the list of packages that we want to install as a part of the system build, and also like it provide allows us to provide the definition for customization. Like we can define the custom system like time zone, customized users like we can build, and there's a lot of things that we can like define it in this definition file to customize our system image. Okay, so that is a part of what is blueprint. Okay, based on that blueprint we are going to build our images. Okay, let us try to understand now compose. Compose is nothing but the individual builds that we carry out based on the blueprints that we have defined. Okay, so every blueprint like we can give a version number and we can try to build build an image based on that blueprint. That step is nothing but composing the image. Okay, it consists of the metadata, the logs that are a part of that image building process, so that all things come under the compose section. Okay, and what is customization? So customization, as I mentioned, it's basically the things that we define in the definition file or the blueprint, like what customization we want to provide for our system image. So that is what customization is all about. Okay, so as you can see, like we can include users, group, SSH keys. So all this type of customization we can define in the blueprint definition file. Okay, so this is a high level like overview of what the image builder tool is and what are the some of the uh, important information that we need to know about this tool before we want to use it. Okay, so let us try to go further and see how we can utilize this tool. So we are going to use a tool which is provided by the fedora. Okay, so first for that we will first need to install that tool. So let us go ahead and install the tool with this command. Okay, so as you can see we are installing. So we can, as you can see, we will be installing the following tools. So the first one is OS Builder Composer. So this is the main tool, which is a backend tool which carries all the system image build activity, and this is Compose CLI. So basically the the client end of the tool, which provides the tools for creating the images in different formats. So we will be using the CLI tool, and the cockpit composer is basically an integration tool for integrating our composer with the Fedora web console. Okay, so it is a kind of a plugin. Okay, so we can use the web console also as a system image build tool by installing this cockpit composer package. Okay, and bash completion is the default package that we install for the command automatic completion. Okay, so let us try to install this. Okay, so this is going to install all the dependent packages also. Let us give it some time. Okay, so right now, like, we have got all the packages installed. So let me clear my screen and let us go into our documentation. So as you can see, we have installed all the prerequisite packages that are required to build the image. Now let us move on into our second step. Okay, so before that, let me tell you. So image builder tool comes with default definition files which we can use. No, image builder tool comes with default repository files. Okay, so as you can see, these repository files are installed at the following location. So basically these are the definitions. Okay, let me open this one of the file. So basically these definition files contain the mirror image information of the repositories from which the packages are going to be installed. Okay, so as you can see, it has the Fedora So as you can see, it contains the Fedora image, basically the packages for this Fedora wherever it is available, that link, and updates. So this is the updates link from where we'll be getting all the packages related to the updates. Okay, let me go further down, and you can see Fedora modules, update modules. So these are the different links that are available from which the repository links from which the the packages are going to be installed for the specific version of the fedora which we are trying to build. Okay, and it is also based on the architecture. Okay, so as you can see, these are the package these are the links for the 8664 based systems, and below you can see that it consists of Arch 64 images links for repositories. Okay, so this is basically the repository file that is going to be used by this tool to actually install the packages within the system, the customized system that we are building. Okay, so let us go further into our second step. So as a part of second step, we need to enable the service as a part. So this is installed as a socket. So we will be enabling this socket service so that it will be up and running on every boot. Okay, so now we have enabled the OS builder socket, and now the second step is to enable the cockpit socket. Okay, so this will make sure like our service is up and running whenever the system is booting up. Okay, so now let us go into our third step, which is basically, as I said, like this image builder tool will help us to build the system images, the customized system images in different formats. So let us see like what are the different formats that are supported by this image builder tool. Okay, so as you can see, like it supports various formats like AMI, it is for Amazon machine images, OCI is for open container interface images, we have VMDK, VHD, and QCOW2 is for OpenShift if I'm not wrong, and the OpenStack images is for OpenStack virtualization that is provided by this product. Okay, so these are the various formats that are supported. Okay, so let us try to build our customized image with one of the format, but before that we will need to create our blueprint, that is the definition file in toml definition toml extension format. Okay, so for that we will be creating this definition file. Okay, so let me create this definition file and copy this content. Okay, so I'm using actually a very minimal example of definition file wherein I'm giving my system image a name, description, and the version of the blueprint, the version of the image that we are building out of this blueprint, that is 001, and modules groups I'm keeping it empty, and the only thing that I have additionally added is we are going to install these two packages. So this is basically the Nginx package, and the SSCG is the certificate generator package. So basically it is going to create the public and private key and the signer certificates it will be able to generate. So this is the package that we are going to install as a part of this system image. Okay, so let us save this definition file, clear the screen. Okay, now we have this definition file which we need to first push it into the backend. So basically it is like pushing the blueprint into the backend so that we can the backend can use that blueprint definition file and create the image. Okay, so let us try to push this definition file into the backend. Okay, so we have pushed it, and let us try to list it. So as you can see, the blueprint is available in the backend. Okay, so now As I said, like we create the definition file and we define the customization, like what type of packages that we want to install and all those things. But before like creating the image, so it is always a good idea to resolve your dependencies within the definition file. So let us try to see run this dependencies solve for this definition file. It is going to take some time so that it gets completed. So once the dependency resolve completes, it will list you all the packages that are going to be installed as a part of this system image build. Okay, so it is going to take a while, so you can try out this step and give it a shot, so that it will show you all the list of packages that are going to be installed along with the packages that we have defined over here. Okay, nginx and sscg. Now let us move on to our next step, that is the important step of creating the system image using the blueprint. Okay, so we are going to use the definition, the blueprint that we have pushed into the backend, and based on that blueprint we are going to create an image, system image, in the format of vmdk. Okay, so here is the command that we will need to run to create this custom image based on the blueprint fed36 customized, which we have created in the last step. So let us try to run this and create our customized image in the vmdk format. Okay, so this is going to take some time. Let us open our different shell and try to see what is the status of the compose. Okay, so basically what is the current status of the image definition that we are creating over here. Okay, so here as you can see, I have run the compose CLI compose status, wherein it is showing the image like image creation is in process, so it is running. So let us give it some time. So once it is completed, it will show as completed, and we will have the image, vmdk image, available for us to download. We can check the logs also for the compose that is currently running. So we need to provide the UUID, universal unique ID of the compose, the image that is currently getting built. So this UUID you can get it from the status. Okay, so once you when you run the status, so the first field that we get is the universal unique ID that we can use to get the logs of that corresponding system image that is getting built. Okay, so as you can see, it is still running, so let us give it some time. Okay, now you can see the image build, the customized image build is completed, so it will show the status as finished. Okay, let me clear my screen and let us try to download the system image that we have built. Okay, so for that let me run that status command again and try to capture the UUID. Okay, so we will be downloading that image using the following command, that is compose CLI compose image and the UUID name. Okay, so this is going to download our image locally. Okay, so as you can see, the image has been downloaded locally. So now we have this image which we can use with the VMware software, because that is the that is a service provider that creates or uses this VMDK file, virtual machine disk file. Okay, so this vmdk file we can use to build our operating system, create our instance out of this this customized image. Okay, so this is how basically we can build the images, the customized system images based on the formats that are supported by this tool, and build the images for various type of virtualization service providers like VMware, uh, VirtualBox. Okay, and for the cloud we have AWS, Amazon, AWS, GCP, and Azure. So these are all the uh, uh, service providers for which we can build this customized images in Fedora and RHEL. Okay, so you can get more details about this OS build tool uh, in the user guide documentation. So let me go into my, okay, so now we have completed like this like tutorial wherein we have seen how we can define our customized image using a blueprint, and we can create our image in various format which we want to build and download that image. Okay, so for more information, like basically you can go into Google and try to search for OS build. Okay, OS build user guide. Okay, so it will take you to the OS build documentation page, and from here you can go into the OS build org guides. Okay, so this is the main documentation page for this OS build composer tool. Okay, as you can see, this is currently available only for Fedora and RHEL. Okay, so this tool can be used only for Fedora and RHEL to build the customized images for various virtualization softwares. Okay, as I said, like these are the different virtualization providers for which we can build the image. Okay, and there is a lot of this information that you can get. And regarding the blueprint reference, if you go into the blueprint reference, as you can see, like this is the blueprint that I have tried to use, but you can get example blueprint over here. If you go down, scroll down, so as you can see, like you can define the packages that we want to install, the host name customization, and the public key of the user that we want to like include as a part of the system image. Okay, and we can define the users. Yeah, like creating it is basically kind of creating the user and groups and mapping those. Okay, so and we can define the file systems also, like as you can see over here. So these are the kind of customizations that we can define in the blueprint, and we can try to build the image out of it. So it is really going to be very helpful for you to build the customized image for various virtualization providers and try to push those images into your cloud provider services or virtualization service provider where you want to use these images. Okay, so there are steps which you can see for like basically how we can push the images that we have created to the cloud service providers for which we have built these images. So these are the things that we can carry out using this tool. The intention, basically the intention was to show you how we can build the customized images, though we have the plain old method of defining our system image using the kickstart file, but that is a bit of complicated. Like we need to understand a lot of things about the system images before we try to create a custom kickstart file, and that kickstart file we can use using the pxe boot by referencing the kickstart file and referencing the initial RAM disk and the base images, base image of the OS build. So those are the things that we need to know about if we want to use the kickstart file to build an image. But that is a bit complicated to understand and in order to like use also. But this tool, like, which helps us to build a customized image in a very simplified manner using the definition file, that is a blueprint file. It will really help you to build the images. So that is the whole purpose of this tutorial, to show you like how we can utilize this tool. But this is specifically for the Fedora and RHEL systems wherein we can build these images. But I think there are various other tools that are provided by the different virtualization providers and the cloud providers that also help you to build the images. So that is a different story. But yeah, so this tool you can try to explore and try to see if that helps to build your customized images and try to utilize in your virtualization environment. Okay, so I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.